Welcome, our dear students, to this morning's class. Today, we still want to continue with expectation of discrete random variable. However, in today's own, we have just lifted some questions to solve concerning expectation of discrete random variable. But in this scenario, it involves evaluating the unknown from the questions. So we just have about 5 questions that we're going to solve with you. First of which is expectation. Talk about expectation still. Of discrete random variable. Discrete random variable. Permit me to write r dot v as random variable. The first question says, and I write, okay, the question says, find the value of k for each of the following discrete probability distribution. Find the value of k. That question number 1 says, find the value of k for each of the following discrete distributions. Discrete probability. Please permit me to write this one as probability distribution, and permit me to write this one as a probability distribution. This is A. A says, this is A. A says what? X. This is P of X. Here is 1. Here is 0.2. Here is 3. Here is K. Here is 5. Here is 0.2. Here is 7. Here is 0.3. Here is 9. Here is 0.1. So this is question number A. That is 1A. When we are done with 1A, we begin with 1B. We have information that the distribution we have is discrete probability distribution. And we are expected to use the knowledge of a discrete probability distribution to evaluate the value of this K. The only thing I will remind us is that when we talk about probability distribution, we are talking about a table containing all the possible values of a random variable. And in this case, it begins from what? 1 and ends at what? At 7. And their corresponding probabilities. For this random variable x to take a value 1, look at its probability. That is why you have here p of x. So in this place x here, when 1 goes in here, you are talking about the probability that this random variable x takes a value 1. Look at its probability. The probability that this random variable x takes a value 3, look at its probability, given to us as k. which of course is what we are required to find in this question. The probability that the random variable x takes a value what 5 is 0.2 down the line. And of course, we know that the probability mass function PMF has a property. The property of that PMF, which I want to recall for us, is properties of what of PMF? Probability mass distribution. Properties of a PMF. Let me write it here. Properties of PMF. The first property of PMF, number I, says that P of x is greater than or equal to 0. That is to say that this probability that x takes up any value within the range is always greater than or equal to 0. Then II. That 0 is less than or equal to P of of x, which is less than or equal to 1. That is to say that the probability that this random variable x takes any value between the range lies between 0 and 1 inclusive. It doesn't take negative value, the value doesn't go beyond 1. And the last but not the least, III says that the sum over the range of this x of P of x is supposed to give us 1. That is the sum of all the probabilities over the entire range is expected to give us 1. And we are going to address this problem using this property number 3, where the sum of all the entire probability is expected to give us 1. These are all the probabilities. So it's expected that the sum of all these probabilities is supposed to give us 1. So solving this problem, I will now say solution then. Solution. I will say that sum over the range of x of P of x is supposed to give me 1. That is what it is. And of course, this sum begins from 1 and ends at what? At 9. But in this case, we should know there is no 2 here, there is no 4 here down the line. So what we are going to do now is to say, therefore, this implies, here is 0.2, I have 0.2 plus. Here is k, this is k plus. Here is 0.2, 0.2 plus. Here is 0.3, 0.3 plus. Here is 0.1, 0.1. The answer is expected to give me 1. That is the implication. So this implies, or this equals, 0.2 plus 0.2 is 0.4. Plus 0.3 is 0.7. Plus 0.1 is 0.8. But I still have this k here. So what I have now becomes what? 0.8 plus what? K is equals what? 1. 0.8 and 1 are like terms, so they should be collected together. So this thing implies, when this 0.8 comes over here, I have that k is equals 1 minus 0.8. 1 minus 0.8 is 0.2. Therefore, my k is equals 0.2. And that 0.2 becomes what? The answer. I repeat. When you have a problem like this, where you are required to find the value of unknown, and that unknown occurs within the probability row, what you are going to do is to sum all the probabilities now and equate to 1 to enable you evaluate the value of the unknown. I repeat, the unknown must occur within the probability row. If the unknown occurs here, this is not going to be the approach. The approach is going to be different. We are going to miss that one. In this case, the unknown occurred within the probability row. When the unknown occurs within the values of the random variable, we use another approach. And that approach is going to be the formula for the expected value of a random variable. So this is how to arrive at the value of this one. Please have this in mind. You can make a little note into your jotter about these three properties of a PMF, probability mass function. That this is equals greater than or equals to this, and this is this, and this is this. They are actually going to help you to trash a lot of questions concerning PMF. So permit me to clean this one down while we take up question number 2 or question number B. So you permit me to clean this one. Question number B says, and I write. Question number B says, and I write. Question number B, this is B now. Okay? So that B says this is X. This is P of X. Okay? So this is 0. This is 5K. This is 1. This is 6K. This is 2. This is 4K. This is 3. This is 3K. Last but not the least, this is 4. This is 2K. Look at the question you are given. And what is expected of you is to find the value of K, because it says find the value of K for each of the following discrete probability distributions. We earlier had looked at A, where we equally found the value of what? Of K. This question is actually coming from this one too, so we are expected to find the value of K. We come down to the discrete probability distribution given to us. We ask ourselves, where is the unknown found? Is it within the row of the values of the random variable or within the row of the probabilities of the values of the random variable? The K, of course, occurred within the row of the probabilities of the values of the random variable. So we are actually going to recurse on the third property of the PMF, which says that the sum of all the entire probabilities over the range is expected to give us 1. So I will now come here and say, using that same information, I will now write solution. Solution. Solution now becomes, this is sum over the range of x of P of x is expected to give me 1. But in this case, the range begins from 0 and ends at what? At 4. No number is skipped. 0, 1, 2, 3, 4. So I can easily say that this implies sum. I won't write this x again. I will say that x begins from 0 and ends at what? At 4. It begins from 0 and ends at 4. Of P of what? Of x. This is expected to give me 1. So what do I do? Summing from 0 to 4 of this P of x means this plus this when x is 0, plus this when x is 1, plus this when x is 2, plus this when x is 3, plus this when x is 4. And in that case, what I now have here becomes what? 5 what? K, plus 6 what? K, plus 4 what? K, plus 3 what? K, plus what? 2K. This is expected to give me 1. So 5 plus 6 will give me what? 11, plus 4, 15, plus 3, 18, plus 2, 20. So what I have here becomes what? 20 what? K is equals what? 1. Making K to stand all alone, I will divide both sides with 20. So it is now going to be 20 what? K all over 20 is equals what? Um, Here is my 1 is equals 1 all over what? 20. So that this and this can go and k is equals 1 all over what? 20. So this becomes the value of k. It was easy for us to solve because we had the idea of the third property of a probability mass function, where the sum of all the entire probability over the range is equals 1. Now let us look at a scenario where instead of the unknown appearing within the row of the probabilities, it does appear within the row of the values of the random variable. So this is not difficult for now. So permit me to clean down the board while we take up some other questions to solve with you. So this time around, I'm going to bring this question down. I'm going to bring this question number 1 down. Okay. Let us look at the question together. The question says, and I write, okay, find the value of k from, yes. Look at the question. That is question number 2. The table is this way. Table says x. This says p of x. Here I have what? I have 2. I have 0.3. Here I have what? 4. I have 0.2. Here I have what? 7. I have 0.4. Here I have k and I have 0.1. The table is closed. They now gave us additional information. They say find a value of k if the mean of this distribution is 5.3. Find the value of k. Find the value of k if the mean of the distribution is 5.3. So we want to approach this kind of question and see how it is solved, where instead of the unknown occurring within the row of the probabilities of the random variable, then it occurred within the row of the values of the random variable. We are now going to solve this kind of problem using the third properties of the PMF. Because the third property of the PMF applies only on the probabilities and not on the values of the random variable. So for us to solve this kind of problem, we are going to look for a formula in statistics that connects values of random variable with their corresponding probabilities. And what is it in statistics that connects the values of the random variable alongside their corresponding probabilities? It is the expected value or expectation of a discrete random variable. And let me remind us that formula. Expectation of a random variable, which is another name, is what is mean, is given as E of x. First of all, let me write solution. And I'll write E of x is given as sum over the range of x p of x. That is how to write the formula for the expected value of a discrete random variable, and this is a discrete distribution. Sum over the range of x p of x. And I had earlier said that another name of expected value is the mean. And they gave us the mean to be 5.3. So in place of this expected value, I am free to use 5.3. So I will now say that 5.3 equals sum over the range of x p of what of x. Okay? Then we go ahead. Now what this implies is, what we are considering is this. We are going to use x and multiply the probability plus. We use the value of x and multiply the probability plus. We use the value of x and multiply the probability till we exhaust this. Look at the value of x here, look at this probability. So we are going to use this, multiply this. Sum here means plus. We use this, multiply this till we exhaust this. And in that case, what we now have becomes what? 5.3 equals. The value here is 2. So I have 2 multiplied by 0.3. 0.3 plus. The value of x here becomes 4. I have 4 multiplied by 0.2. 0.2 plus. The value here is 7. So I have 7 multiplied by 0.4. 0.4 plus. The value here is k. We have k multiplied by 0.1. You now can see that this k has been factored into this equation. And with that, we can easily evaluate its unknown. So what we are going to do here now becomes, this is what 5.3 equals 2 times 0.3. Permit me to use my calculator so that it will be much easier for me. We are talking about 2 multiplied by 0.3, 2 times 0.3. So, of course, we have 0.6 to carry everybody along plus 4 times 0.2. Definitely, we are going to have 0.8. So, we are talking about 4 times 0.2. We have 0.8 plus. We have now 7 multiplied by what? 0.4. So, we have 7 multiplied by 0.4. We have a 2.8. So we have 2.8 plus. And then we have k times 0.1, which is 0.1 k. So we have a 0.1 k. So this thing now becomes again that this is 5.3 equals 0. We are going to sum all these things together. 0.6 plus 0.8 plus 2.8, 4.2. So I have 4.2 plus 0.1 k. If you watch here, 5.3 and 4.2 are like them. So they can be collected together by this one coming to meet 5.3. So this thing becomes what? 5.3 minus 4.2 equals 0.1 k. 5.3 minus what? 4.2 will give us 1.1. So we have what? 1.1 equals 0.1 k. To make k stand alone, we divide both sides with 0.1. So all over 0.1, all over 0.1. So at this 0.1 can cancel this 0.1, and we have k left. So 1.1 divided by 0.1, divided by 0.1. Will be able to give us 11. So we now say, therefore, our k is equals 11. You see the value we got here is not a probability value. Instead, it is a value of a random variable x. If it were a probability value, it's going to be a value less than 1 and a value that is non-negative. So this 11 here stands for the value of the random variable, which actually should be in this place. So the probability of this random variable x taking up a value 11 is 0.1. While the probability that it takes up a value 2 is 0.3, it takes up a value 7 is 0.4 down the line. So this is how to find the probability to find the value of an unknown when that unknown occurs within the row of the values of the random variable. You recall the formula for expected value of a random variable, which is another name is what is mean. And then you use the formula to the above now to evaluate the unknown. Thank you very much. Permit us to equally clear here and take up also another question which you are going to maximally benefit from. Another thing I want to let you know is that when the unknown is just 1, with a single equation, we can find the value of what of the unknown. You know that. That in a simple linear equation, we can easily find the value of one unknown. But when the unknown becomes 2, we can no longer use a linear equation, simple linear equation. Instead, we are going to use the idea of a simultaneous equation. So let us now look at other questions where some of them might be involving 2 unknowns and we are required to find their values. So permit me to clean here. Okay? I want us to look at this question together. Very wonderful question. That question says, and I write, that becomes our question number 3. Permit me to equally clean this. That becomes our question number 3. That question number 3 says, number 3. It says, find the values of A and B. Find the values of A and B from the following probability distribution. From the following probability distribution. Please permit me to write the probability distribution this way to manage this my board. They say if E of x equals 4.29, and the table is, this is x, this is P of x. P of x. So here is 1, here is 0.1, here is 2, here is 0.1 still, here is 3, here is A, here is 4, here is 0.3, here is what? 5, here is 0.2, here is 6, here is B, here is 7, here is 0.2. And that is the question they ask us to find. So I would want to call our minds to the presence of 2 unknowns here. There is unknown here. There is unknown here. So this time around, it is not going to be handled by a single linear equation. We are going to look for 2 questions that can be solved simultaneously that involves this A and this B. And the another question we're going to ask ourselves is, this A and B, in which row of the table do they appear? They appear in the rows of the probabilities of the random variable x. So we are going to now apply the third properties of the PMF, which says that the sum of all the probabilities over the range beginning from 1 to 7 is 1. And that principle will help me to do correctly that, or to say correctly that I will now begin with solution as usual. Solution. That the sum over the range of x of P of x is equals 1. I will say this. And if you agree with me, which of course we had earlier met, this implies 0.1 plus 0.1 is 0.2, plus 0.3, 0.5, plus 0.2, 0.7, plus 0.2 will now give me 0.9. So I repeat, 0.1 plus 0.1, 0.2, plus 0.3, 0.5, plus 0.2, 0.7, plus this 0.9. So I have 0.9 plus A plus B is equals 1, because the sum of all the probability must give us a 1. And of course, this and this becomes like terms. And in that case, I'm going to say, therefore, when this 0.9 comes over here, 1 minus 0.9 will give me 0.1. So I have that A plus B equals 0.1. I will call it equation 1. Equation 1. Then I am done applying what I know that concerns the probabilities of the values of a random variable. But because there are two unknowns here, I cannot solve this equation in order to find the values of A and D. No. If it were only one value, I don't have a problem. So I will now come back again here and still look for another thing that connects the values of what of a random variable and their corresponding probabilities, which of course is the expected value. And that's why they gave me this information. So I have been able to evaluate this one using the property of PMF. Here I will now come and look at what they gave me here, information they gave me here. That the expected value is given as this. And you and I, of course, already know from our past question that expected value is given as sum that E of x, or let me say sum over the range of x, P of what of x is given as what E of x. And my E of x is given to me to be this. So, and this thing means you use the value of x to multiply the probability plus. Use the value of x to multiply the probability plus. Because this sum is actually the plus I am saying. Okay? So the value of probability is 1 here. So the value of the random variable is 1 here. Its probability is 0.1. The value here is 2. Its probability is what? Is 0. This. So I'm now going to have another equation that says, I'll come here. This is 1 multiplied by 0.1. 0.1 plus. This is 2 multiplied by 0.2. 0.2 plus. This is 3 multiplied by A, which is 3A, direct, without wasting time. This is 4 multiplied by 0.3. 4 multiplied by 0.3 plus. This is 5 multiplied by 0.2. This is 5 multiplied by 0.2 plus. This is C multiplied by B, which is 6B plus. This is 7 multiplied by 0.2. This is 7 multiplied by 0.2. We are told that this is equals 4.29. This is 4.29. So we are going to use calculator in order to evaluate this. But 1 times 0.1 is 0.1 anyway. 0.1 plus. 2 times 0.2 is actually 0.4. So I have 0.4 plus. Here is what? 3 what? A. Here is 4 times this will actually give me that is 1.4 times 0.3 will give me 1.2. That's 1.2 plus. This time this will actually give me, that is going to be 1. This is 0.2 times 5 will be able to give me 1.0 plus. Here is my 6b plus. This time this will actually give me 1.4. So 7 times 2, 0.2 will give me 1.4. This equals 4.29. So at this point in time, I will come to sum all of these. 0.1 plus 0.4, 0.5. Plus 1.2, 1.7. Plus 1, 2.7. So I now have 2.7 plus 1.4. 2.7 plus 1.4 will give me 4.1. So everything becomes 4.1. So I have 4.1 plus this my 3a plus this my 6b equals 4.29. And know you that this 4.1 and 4.29 are like terms. So this one can actually come over here. And when it comes over here, it becomes 4.29 minus 4.1. So talk about 4.29 minus 4.1. So that will give us 0.19. So which means what I have here becomes that 3a, this is 3 what? A plus 6b equals 0.19. Equation what? 2. It is at this point in time that we can solve these two systems of equations simultaneously in order to find the value of A and B. It can either be solved using substitution method or it can be solved using elimination method. If you want to solve using substitution method, you are going to make a sort of formula from equation 1. And making a sort of formula from equation 1, B goes over there, and you have that A is equals 0.1 minus B. You come back here, anywhere you see A, you replace with this in equation 2. So what you have here becomes, therefore, here is my 3, you open a bracket. A is already 0.1 minus B, so you have 0.1 minus B. You close it. Plus this 6B is equals 0.19. So you have 3 multiplied by 0.1 will actually give you 0.3 minus what? 3 what? B plus 6 what? B equals 0.19 by using this 3 to open the brackets. Okay? Now this 3 goes over there, it becomes minus. And here you are owing 3, but you have got 6. So, which means what you have left here is what? 3b equals. When this 3 comes over there, we have a 0.19 minus 0.3. So, you have a 0.19 minus 0.3. This is 3 multiplied by 0.1. 3 multiplied by 0.1. 3 times 0.1, which gave us 0.3. Okay? So this multiplied by this, which gave us that value. So we have that 0.19 Okay, we need to closely look at where the sum is. Here is 0.1. This is 0.2. This is 0.5. This is 0.7. This is 0.9. Okay? So in that case, I have 0.9 plus a plus b equals 1. So this one is correct. So let us come here to cross-check this one better. 1 times 0.1, which gave us 0.1. 2 times 0.2, which gave us 0.4. So 4 times this, which gave us 1.2, which gave us 1, which gave us 1.7. So let me first of all add up all this. This is 0.5. 0.5 plus 1.2, 1.7 plus 1, which gave us 3.7, plus 1.4, which gave us 4.1. Okay. And then bringing this 4.9 here, 1 here, it is going to be minus. So what I'm going to have now becomes 4 points, which is actually correct, which gave this 0.19. Okay? And then making this a sort of formula, we have 0.1 minus b, putting it here. Okay? I want to actually find out why this b is turning to be negative. It's not expected to be negative. When you cross-check it well, it's not expected to be negative. It's actually meant to give us a positive value. Okay? The first one is a plus b equals 1. Okay? Oh, I'm seeing 3.9 somewhere. 3.9 somewhere. Okay? Okay, let me cross-check the values again in the table. 0.1, 0.1a, 0.3, 0.2, and equal to 0.2. Okay? But the most important thing here is, it may be from this table that I recorded something wrongly. That's why this value is trying to turn out negative. Or when I was assisting myself to do this multiplication, because you know it is involving a decimal point and doing it concurrently while solving the problem might actually pose some level of challenges. The only thing I can assure you is that if you do your multiplications clearly, this value of b and a are actually going to be positive because they are probability values. And the moment you see two unknowns, you recurse to using simultaneous equation.